Okay, so this is going to be the second video in the arithmetic and geometric sequences unit. This one's going to be pretty short. We're just going to be talking about one specific skill, which is based on IXL P4. It's a little bit more complicated, so we're going to take it kind of slower. This one should be maybe a little bit trickier for some of you. So below, this says here, we can identify the type of sequence based on its formula. So basically, when you see this exponent right here, you know that it's going to be a geometric. So basically, we have 4 times 3 to the n. So what this tells us is that we start with 4. We're going to multiply it by 3 each time for whatever the sequences are. So 4 times 3 to the n is geometric. So whenever you see an exponent with an n in it, you know it's going to be geometric, just straight up. When we have 3n plus 5, this is a linear term. So this is like what we'll see in class a lot of is stuff like 3x plus 5. And anytime you have a variable like this, where it's just multiplied by something else, it's going to be linear in nature. So this is going to be arithmetic. This is a little bit more confusing because it's just a number times this n here. What this says is -5 times whatever n is. So the first term would be -5 times 1, which is -5. The second term would be -5 times 2, which is -10. Third term would be -5 times 3. So, which is -15. So you can see we're going down by 5 every single time. So this is also arithmetic. Now, if you're ever in doubt, what you can do is just plug in 0, 1, 2, 3, 4, whatever, to solve for these. So like if I plugged in 0 here, I'd start with 5. And I plug in 1, I have 1 times 3, which is 3, plus 5, which is 8. If I plug in 2, I have 2 times 3, which is 6, plus 5, which is 11. So you can see that that's an arithmetic sequence right here. 4 times 3 to the n, if I plug in 0, I have 3 to the 0 is 1, so be careful with that. 1 times 4, which is 4. Then I have 3 to the 1, which is 3 times 4, which is 12. Then I have 3 to the 2, which is 3 squared, or 9. 9 times 4 is 36. And then it'd be 3 to the 3rd, which is 27. 27 times 4, which is 108, and so on and so forth. So as you can see, there's multiplying by 3 every time. This is a geometric sequence. And this one is subtracting 5 every time, so we know it's arithmetic. This one's adding 3. And you'll notice that the difference is equal to the number in front, number in front. For this one, number in front, number in front. And then for these geometric sequences, it's whatever number is being raised to this power. So 3 in this case. Using the formulas to find terms. This is what we're actually doing in the IXLs. This is also actually probably the most important part of this unit. This is kind of the main thing we actually want to do here. So a lot of times in the real world, we can come up with a formula to actually like get a sequence or figure out how some numbers are going to work in whatever form. And we want to be able to figure out, let's say, the 512th term or whatever. We can do this by using the formulas. So that's what we're going to do here. So these are all arithmetic formulas. They're all something times n plus some number, or just something times n. In this case, we can think of this as plus 0. But basically it's something times n. So what we want to do, let's say we want to find n equals 3, n equals 1, so we can figure out the first term in each sequence, and n equals 12. So we're going to plug each of these in for each one of the formulas. And we'll start with n equals 1 for each one. So if we plug in 1 for n, we'll have 3 times 1 plus 4. 3 times 1, that's equal to 3, plus 4, that is 7. Then if we want to find n equals 3 for this first one, we're going to have 3 times 3 plus 4. 3 times 3 is 9, plus 4, that gives us 13. And then the last one, if I want to figure out what the 12th term is, I'll have 3 times 12 plus 4. 3 times 12 is 36, plus 4, that gives us 40. So the 12th term in my sequence would be 40. T sub 12 equals 40. T sub 3 equals 13. And T sub 1 equals 7. We can do the same thing on the next one. So I have -2 times 1 plus 12. -2 times 1, that's -2 plus 12, that is 10. So that's T1. And then if I do -2 times 3 plus 12, -2 times 3 is -6 plus 12, that's +6, T3. And then the last one, we have -2 times 12 plus 12. -2 times 12 is -24 plus 12, that equals -12. So this is T sub 12. Last one, we're literally in this case, since we're not adding anything, we're just multiplying the numbers. So 5 times 1, which equals 5, that's T1. 5 times 3, which equals 15, and 5 times 12, which equals 60. So we can also use these formulas to create a table of values. And so what this does is actually probably the most important part of this. This isn't what you'll see on the IXL itself, but this is kind of something that you do need to be able to do. And this is actually really important here. So for the ends, I can put in whatever term numbers I want. Generally speaking, I'm going to put in starting with 1 and just go up by 1 because it makes my life a lot easier. So 1, 2, 3, 4, and 5. And then what we're going to do is we're going to plug in this number for n and solve it. So I plug in to get my first term. I'm going to plug in, this would be my first term. I'm going to plug in 1 for n. So I'll have 3n, 3 times 1 plus 4. 3 times 1 is 3 plus 4, that's 7. So 7 is what I'm going to put in this box. And I didn't do this incredibly intelligently, so we're going to try this and see if the red shows up. Yeah, okay, it'll work. So let's rewrite this. 2, 3, 4, 5. We just calculated this one out to be 7. So then we plug in 2 for n. We have 3 times 2 is 4. 3 times 2 is 6 plus 4. It's 10. Then we do 3 times 3 plus 4. 3 times 3 is 9 plus 4. That's 13. 3 times 4 plus 4. That's 12 plus 4, 16. And 3 times 5 plus 4. That's 15 plus 4, that's 19. So same idea here. We'll go 1, 2, 3, 4, and 5. So we're going to have -2 times 1 plus 12. -2 times 1 is -2 plus 12, that's 10. -2 times 2 plus 12. -2 times 2, that's -4 plus 12, that's 8. Now, I could go through and do the same thing, multiply -2 by 3, add it to 12, do that over and over again. But remember, these are arithmetic sequences, which means that it's going to change by a constant rate every single time. So if I have the first term, then the second term, then the third term, the fourth term, each term it's going to go down by 2. So all I have to do is subtract 2. And this is called solving this recursively, which is a really fancy way of saying that we're coming up with something that's based on the previous term. So instead of actually solving out for each individual term, we're using the previous term in order to solve the next one. Now in this last one, I'm going to do something a little different. I'm going to go 1, 3, 5, 7, and 9. So instead of solving just for the first, second, third, fourth, and fifth term, I've chosen to do these ones. There's no actual reason that you'd have to do this ever, but if you were given a table that looked something like this, you could use it and still solve all of these. And you can actually do it with a pattern. I'll show you partway through. So again, we're just going to plug whatever n is into this formula. In this case, it's just 5 times n. So we have 5 times 1, that's 5. And we have 5 times 3 for our next term. It's going to give us 15. And then we have 5 times 5, which will give us 25. Now, because I am going up by the same amount each time here, I'm going to be going up by the same amount each time on the bottom. So we're going up plus 10, we're going up plus 10. I'm going to go up again plus 10, so we know this is going to be 35. And then again plus 10, which is going to be 45. And the interesting thing is actually how we can work backwards from this. So in order to figure out what the rate of change was here, we were given it because we have a formula. But if you had a table like this where it went 1, 3, 5, 7, 9, in order to figure out how much is changing in between each term, you'd actually have to take half of this. So instead of going up by 10 each time. It's only going up by 5 each time, but since we're skipping every other one, it looks like it's going up by 10. And we're going to talk more about doing going in reverse on this later. We'll do that in our normal 8th grade class too. But this is just something that you need to be aware of, or at least should have seen at least once, so you don't get confused if it does come up while you're going through the work. Now this is the geometric version. So this is a little bit more complicated because these numbers get really big, really fast. It's important to be able to solve these pretty easily. So instead of going with the 1/3 and 12th term, I'm going to go with the n equals 0 term, the n equals 1 term, and the n equals 3 term. And I'm just going to do like one of them or all three for the first one, and then I'll do probably the n equals 3 for the other two. I'm not really going to waste the time to go through all of them. So here we have 4 to the power of 0 for the first one, which is just equal to 1. So that's easy. Generally speaking, you don't use the 0th term just because that means it's before we've actually started. But in this case, just so that you can see what it'll look like, we put it up there. So the second one, we have n to the 1, so 4 to the 1, which is just 4. And then 4 to the third, that's equal to 4 times 4 times 4. 4 times 4 is 16, times 4 again is 64. And here, let me change this back to white so we can see a little bit better. So the next one, I'm going to solve for the third term. I'm not going to bother with the 0 and the 1. So we have 2 times -2 raised to the power of 3. Now, it is important to notice here that I am kind of doing something that I told you not to do during the exponent unit. Because this term is in parentheses, it gets a little bit confusing as to whether or not you should change the power. If you're having a negative number down here, it's always going to switch back and forth between being a positive and a negative. So we're going to do -2 times -2 times -2, which is equal to -2 times -2 is +4 times -2 again, that's -8. So that's what we're putting in here. So 2 times -8, and 2 times -8 gives us -16. So our third term for this sequence would be -16. And for the last one, again, for the third sequence, now we started at -3. And what you're going to notice is since the negative number this time is out here, I'm not actually changing back and forth as I go. So we'll look at this more when we get to the tables on the next page, but this times 2 to the third. 2 to the third we just established is 8, so -3 times 8 gives us -24. And I know I'm kind of skipping a step there, but I think you guys can figure out the actual math part of that pretty easily. But if not, we're going to look at it right here. So let's go ahead and do this. So here, I am, again, just because these are geometric, the numbers get really big really fast, I'm going to start with 0. You probably should not generally do this. I believe the test does not give you this many that you have to calculate out for the geometric sequences, but I'm not 100% sure. So we have n 0, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, and 4. You'll notice this time I'm not skipping around. And the reason for that is just because skipping around here would be a huge pain. So we know that anything raised to the power of 0 is going to be 1. So 4 to the n, or 4 to the 0 is going to be 1. If we plug that in here, we're going to have -2 to the 0, which is still +1. That's important to keep in mind. It's always +1. So +1 times 2, that's 2. And then -3 times 1 is going to be -3. So that 0th term is really easy to fill in for all of these. It's just whatever number is in front, which in this case, you can think of this as 1 times 4 to the n, but that's not particularly needed here. Let me erase this. Okay. Moving on. So now we're going to do 4 to the 1 to solve for our first one. 4 to the 1 is just 4. That's easy. 4 to the 2, that's 4 squared, which is 16. We already saw 4 to the 3 on the last one. It's 64. And then we need to do 4 to the 4th. So 4 to the 4th is equal to 4 times 4 times 4 times 4. We know that this is 64. Multiply that by 4. We're going to get 256. Now, again, I don't know that we'd expect you to go too much higher than this. You could multiply this by 4, get 1024, and then go again. But this very quickly gets to really big numbers that you're not going to want to work with. So we generally try to just stay on the front half of these, or the front side of these. work mostly with the smaller versions of them when we can. So here we're going to have -2 to the 1. That's -2 times +2. That's going to give us -4. Then we're going to have -2 squared times 2. -2 squared is +4 times 2 is 8. Now you'll notice that this is a changing, so it's changing from positive to negative to positive. So this next term we know is going to be negative. We did this on the last page anyway, so we already know that this one's 16. And then what you'll notice is these are doubling each time. And then we're also switching the sign because it's actually being multiplied by -2. So we can just double this and make it positive, get 32. Then for the last one, we're doing, again, it's 2 to the n. So we're going to have -3 times 2 to the 1. 2 to the 1 is 2. 2 times -3 is -6. We're going to have -3 times 2 squared. 2 squared is 4. 4 times -3, -12. So you'll notice that these ones, they're also doubling, and this time the negative is staying constant. We're not actually changing the negative back and forth. That's because this number out in front is the -1 this time, instead of the negative that's being raised to a power. So the multiplier is +2, and no matter how many times you multiply a positive in, it's not going to change the sign. The multiplier on this one is -2, so every other time the sign's going to switch back. That's just something, again, worth noting. It's not necessarily something that you need to know. As long as you can calculate these out, you're going to be just fine. So again, I just started doubling these across instead of having to figure out each one every single time. I believe, oh, okay, hold on. Yeah, so this is the last thing we want to look for. So here, we're going to do these last couple. We're going to find the specific terms in these sequence. So this first one, 3n minus 2, it wants us to find the 7th and the 12th term. So to do this, we just have to plug in the numbers for n. So to find the 7th term, we're going to do 3 times 7 minus 2. 3 times 7 is 21 minus 2 equals 19. So our 7th term is 19. 12th term, we just do the same thing. So 3 times 12 minus 2. 3 times 12 is 36 minus 2. That equals 34. So here we have 34. So these are the two terms that they were looking for here. And you'll notice we didn't have to write all of them out, which is really nice because otherwise that's kind of a pain. This one's going to get a little trickier. We've got 4 times 2 to the n. So we're going to have, for the 5th term, 4 times 2 to the 5th. 2 to the 5th is 32. 32 times 4 is 128, I believe. You could actually calculate that out if you want to. Solving this, and actually I should probably mention for this unit, I'm fine with you guys using calculators. I believe I will double check with the algebra teacher. So maybe not. Ask me if you're not sure. But I think you guys get to use a calculator for this. And then for the 8th term, so this one's 128. For the 8th term, it's going to get big. We have 4 times 2 to the 8th. 4 times 2 to the 8th is, okay, let's see. 2, 4, 8, 16, 32, 64, 128, 256. So we have 4 times 256, which is equal to 1024. So this is 1024. Now, again, these are pretty big numbers. Hopefully you guys could do this by hand if you absolutely had to, but I know that most people wouldn't want to, and I would not particularly blame you there. So here, find the 42nd term. So we're going to plug in 42 for n. 5 times 42 plus 3. 5 times 42, that's 210. Plus 3 is 213. So this one, 2, 1, 3. So that's how we find the specific terms. And again, this is all about just plugging in the numbers and solving, so it shouldn't hopefully be too bad, especially if I do let you use a calculator. I'm still not sure yet. Again, I'll double check and let you guys know pretty quick. But yeah, this is all we really need to know for these things. So this should get you through IXL P4. There's going to be one more video that we're going to talk about that you guys should watch once you're done with that. It'll be for the last 2 IXLs, and then you'll be ready to take on the study guide and eventually the assessment for this. So that should be it.